Glass had been used for hundreds of years to decorate or construct objects and buildings. Today, the glass production process is a very complex set of operations to transform raw materials into glass. One of these types of process is the float glass production process. Officially, the process was invented by Sir Alistair Pilkington in 1952. Its name has come for the most important part of the project, in which the molten glass floats inside the machinery. This process has also been called the Pilkington process by the inventor and the industry where it was invented. Pilkington is a Japanese-owned glass manufacturing company and was founded in 1826. The process is begun with the reception and addition to the raw material to the industrial machinery. Technically and according to its proportion, the process requires 72.6% sand, 13% soda ash or sodium carbonate, 8.4% limestone, 4% dolomite, 1% alumina, and 1% of other possible material. The soda ash make easier melting, the limestone adds the durability, and the dolomite adds working and weathering properties. Also, recycled glass is an important component for this first stage since by being added, it greatly facilitates the process. The production process is composed of 7 stages with their own characteristic and operation. The first is molten and refined. At this stage, the materials are mixed to make a batch that is floated like a blanket over a 1500 degrees Celsius furnace to make molten glass. Thanks to the recycled glass, the process becomes 5 times faster. The second is the floating bath, which is considered the heart of the process. After breaking in the furnaces, the glass from the smelter is laid smoothly over a refractory peak on the mirror-like surface of the molten tin. A solid ribbon is obtained after going through a temperature change from 1100 to 600 degrees Celsius. At this stage, the upper and lower surface of the glass are transformed into perfect plane parallels. The third is the coating. When the glass is already placed in a long plate, it is covered with extra materials. These coating that make profound changes in optical properties can be applied by advanced high-temperature technology to the glass cooling belt. The fourth is the annealing. Despite the ease with which float glass forms, considerable stress is developed in the tape while it cools. Too much tension will cause the glass to break under the cutter. To alleviate this stress, the tape is heat-treated in a long oven known as a lia. In the end, the temperature has decreased from 600 to 25 degrees Celsius. The fifth is the inspection. A high level of quality is required in float glass, so this stage is vital to maintain its characteristics. This process is performed by scanners that identify imperfections. The sixth is the cutting. In order to obtain the most acquired parts possible, diamond wheels are used by Pilkington to trim the selvage following the measurement indicated by the computer according to the client's order. The excess of glass in this operation is reused in the mixing process, so no one of the material is wasted. Finally, the seventh stage is the packing and shipping of the glass to the clients with the help of robotic arms and transport vehicles. After all this process, float glass can be used for so many jobs that it is difficult to be counted. For example, it can be employed in architectural products as an aid in energy control, protection against fire or noise, incorporating self-cleaning properties, or just as a decoration, among other applications. It also can be used in the automobile industry, and it has opportunities in solar technology, where flow glass has become the main component of its construction, among many other uses. Now, every time you use your phone, look out your car window, close your garden doors, or use a modern table, will you have realized all the possibilities that flow glass can offer?